Imagine an ordinary Tuesday, 66 million years ago. A world drowning in greenery and the roars of giants. And then the sky splits open. This wasn't just a meteor. It was a rock the size of Mount Everest, traveling faster than a bullet. Its entry into the atmosphere turns the air into plasma. The flash is so bright that creatures thousands of kilometers away are instantly blinded. Impact. The Earth shudders as if struck by a colossal hammer. At the impact site on Mexico's Yucatan Peninsula, rock instantly vaporizes, blasting into space as molten glass. The shock wave flattens forests like dry grass. A global firestorm engulfs entire continents, incinerating everything that didn't manage to hide. Earthquakes so violent that mountains literally crumble into dust. Within minutes, the world of the great reptiles becomes a living hell. But was this single impact the only reason for their demise? Or had the planet been quietly killing its rulers long before the celestial visitor delivered the final blow? The world before the catastrophe. Earth at the end of the Cretaceous. Late Cretaceous period. If you could travel back, you wouldn't recognize your home planet. It was a world suffocating from its own abundance and humid heat. The continents, once fused into a single supercontinent, had fully drifted apart, forming giant islands separated by warm, shallow inland seas. Sea levels stood hundreds of meters higher than today, and the climate was uniformly subtropical across the entire globe. There were no polar ice caps. Even in Antarctica, now locked in eternal permafrost, dense coniferous forests thrived, and dinosaurs roamed along riverbanks. This was the true golden age of biological perfection and simultaneously a period of dangerous stagnation. In forests already populated by the first flowering plants and broad-leaved trees, wandered multi-ton herds of triceratops and armored ankylosaurs. Lurking in the shade of gigantic ferns waited the greatest land predator in history, Tyrannosaurus rex, the pinnacle of carnivorous evolution. The skies belong not to birds, but to majestic pteranodons and Quetzalcoatlus, whose wingspans rivaled those of small private airplanes. And in the warm, milk-like depths of the oceans cruised 10-meter mosasaurs, true sea dragons, without natural rivals. But look closer, and the idol appears disturbingly fragile. The ecosystems of the late Cretaceous resembled an overstretched string, ready to snap at the slightest touch. After millions of years of prosperity, dinosaurs had become overly specialized. The gigantic herbivores were hostages to their own size. They required colossal territories and staggering amounts of vegetation just to stay alive. Even a minor change in plant life threatened them with starvation. Meanwhile, the planet was showing signs of restlessness. Continental drift altered ocean currents, gradually cooling the seas and creating sharper seasonal temperature swings. Biodiversity began to slowly but steadily decline. The world was no longer the eternally stable paradise it had been for the previous 100 million years. we're used to picturing dinosaurs at the peak of their glory, but in reality, they were already standing on the edge of the abyss, completely unaware. Their greatest strength, their massive size and dominance, had become their greatest vulnerability. The planet was changing the rules, and those who had always won through brute force and gigantism found themselves trapped by their own specialization. The Great Age was already drawing to a close, long before the first spark of catastrophe lit the sky. Theory Hasson. Asteroid, the executioner from the heavens. For a long time, scientists searched for the single killer capable of wiping out the planet's rulers overnight. In the late 1980s, we found it. Hidden beneath hundreds of meters of sediment and the waters of the Gulf of Mexico lies the Chicxulub crater, the most terrifying scar on Earth's body, left on the day time stopped for the dinosaurs. A 10-kilometer stone projectile traveling at 20 kilometers per second slammed into a shallow ocean. The energy released defies human imagination. Equivalent to billions of Hiroshima-sized atomic bombs. This wasn't an explosion in the usual sense, it was an instantaneous breach of atmosphere and crust. At ground zero, rock turned to vapor. Within a 1,000-kilometer radius, everything living was vaporized in the first seconds. The impact generated tsunamis hundreds of meters high that swept across coastlines on every continent like moving walls of water and mud, carrying marine creatures far inland. But the real nightmare unfolded in the sky. Billions of tons of molten glass, dust, soot, and sulfur compounds were blasted into the stratosphere. As they fell back to Earth, these incandescent particles turned the atmosphere into a global grill, igniting forests worldwide. Then came darkness. Dust and sulfur enveloped the planet in an impenetrable shroud, reflecting sunlight back into space. A nuclear winter arrived without any nuclear weapons. Surface temperatures dropped 20-30 degrees Celsius, 36-54 degrees Fahrenheit in many places. The world sank into icy twilight for months, perhaps years. Without sunlight, photosynthesis halted. Plants, the foundation of life, withered and died. Next came the giant herbivores that needed hundreds of kilograms of fresh greenery every day. When the last hadrosaurs starved, the great carnivores followed. The food chain, carefully built over millions of years, collapsed like a house of cards. The asteroid became the merciless trigger that instantly rebooted Earth's biosphere. Yet modern paleontologists increasingly ask, could even such an extreme event have been so perfectly selective? Could one, albeit unimaginably powerful impact, really erase the dominant class that thrived across every continent? Or did the asteroid simply pull the trigger on a gun that nature had already pressed to the dinosaur's temple? Theory #2. Volcanism. Fire from the underworld. While one death hurtled toward Earth at cosmic speed, another equally terrible death had already been raging for thousands of years, from the planet's molten interior. Long before the fatal asteroid crossed the Moon's orbit, modern-day India became the stage for a geological nightmare, now known as the Deccan Traps. These weren't ordinary cone-shaped volcanoes. This was a global rupture. Earth's crust literally tore open like overripe skin. And through gigantic fissures, millions of cubic kilometers of basaltic lava erupted under unimaginable pressure. Imagine an area the size of half of Europe turning into a continuous sea of liquid fire that froze in layers 2 kilometers thick. But lava was only the visible part of the disaster. Along with it came unthinkable volumes of carbon dioxide, methane, and sulfur dioxide. The planet began to convulse in a feverish rhythm. First, massive CO2 injections triggered a suffocating greenhouse effect. Temperatures soared, turning jungles into scorched wastelands. Then sulfur clouds blocked sunlight, causing abrupt cold snaps and endless acid rain. Those rains altered ocean chemistry, driving acidification. It was a death sentence for plankton and mollusks, the very foundation of marine life. Today, scientists wrestle with a crucial question: what was the decisive factor? Research shows the most violent phases of the Indian eruptions strangely coincide with the Chicxulub impact. A bold hypothesis suggests the asteroid strike sent seismic waves so powerful they passed straight through the planet, detonating mantle reservoirs beneath India and turning severe volcanism into a planetary catastrophe. It was the perfect 1-2 punch. The sky fell on the land, and the land beneath their feet turned into a boiling inferno. Dinosaurs were caught in a vice between an icy hammer from space and a blazing anvil from below. Theory #3. Climate change. The Great Fading. What if the end of the Age of Giants wasn't a sudden explosion of violence? The gradual climate change theory paints a different, no less tragic picture. Dinosaurs may have slowly faded over millions of years. At the close of the Mesozoic era, the face of the planet changed beyond recognition. The ancient supercontinent Pangaea had completely broken apart, and newborn oceans began dictating new conditions. Sea levels became extremely unstable. The vast inland seas that had moderated climate for millions of years began to retreat. Huge tracts of land emerged, and the fertile coastal lowlands, the true breadbaskets of the dinosaur world, simply vanished. Eternal lazy summer gave way to distinct seasons. Temperature swings became normal. Now, every inhabitant had to endure harsh winters and prolonged droughts. The fossil record supports this decline. Over the 10 million years before the asteroid strike, the number of dinosaur species steadily decreased. Their world grew colder, drier, and more hostile. Biodiversity is any ecosystem's immune system, and by the time the cosmic blow arrived, that immunity had been fatally weakened. Extinction may have been a long, agonizing process of degradation in which the asteroid was not the sole cause, but merely the dramatic and merciless final chord in a sorrowful symphony of decline. Theory #4. Falling sea levels. Life in retreat. Oceans are not just giant water tanks, they are the lungs and primary thermostat of our planet. Throughout most of the Mesozoic, enormous areas of the continents were flooded by shallow epicontinental seas. But at the very end of the Cretaceous, a sharp tectonic shift triggered global regression. Sea level began to plummet rapidly. Where life once thrived in warm lagoons, colossal areas of shallow continental shelf were exposed and turned into lifeless, sun-baked salt flats. This process dealt a devastating blow to marine giants. The graceful plesiosaurs and ferocious mosasaurs suddenly lost their familiar hunting grounds and safe breeding sites. Their living space collapsed before their eyes. But the domino effect reached far beyond the deep sea. Changing coastlines and the disappearance of vast reflective water surfaces radically altered atmospheric humidity and rainfall patterns across continents. Mass die-offs of marine ecosystems, including coral reefs and plankton communities, triggered an immediate collapse of food webs that invisibly linked ocean and land. Birds and small predators that fed along the shore lost their food supply, sending extinction waves deep into the continents. Life on Earth began to shrink, losing precious space and turning a once unified, thriving world into scattered, isolated islands of survival where competition for resources grew ever more brutal. Theory #5. Biological factors, the invisible war. Throughout Earth's history, the mightiest rulers are sometimes brought down not by falling stars, but by microbes invisible to the naked eye. The biological hypothesis argues that dinosaurs fell victim to their own success. With the appearance of new land bridges connecting previously isolated continents came chaotic species migration, and with them, deadly diseases. Ancient pandemics caused by viruses and bacteria, to which local populations had no natural immunity, could wipe out entire herds in weeks, turning flourishing valleys into graveyards of giants. But the threat didn't come only from the microbial world. Add ambitious new neighbors, mammals. At that time, they were small and inconspicuous. Yet they possessed a decisive advantage: warm-bloodedness and high metabolism. While giant reptiles stiffened in the night chill, these agile creatures could systematically raid dinosaur nests under cover of darkness. For a gigantic species that needed decades to raise even one individual to reproductive age, systematic loss of offspring was a demographic catastrophe. Layer on an evolutionary explosion of parasitic insects, ticks, blood-sucking flies, new species of lice acting as vectors for exotic fevers. This biological war was waged on an invisible front for millions of years, steadily eroding the health of entire species. Dinosaurs didn't die from a single cold, but these factors left their populations genetically weakened, exhausted, and fatally vulnerable to the global upheavals already looming on the horizon. Theory #6. Cosmic factors, silent killers from the void. When searching for the causes of the greatest catastrophes, we often look to the sky. But some scientists urge us to look much farther, beyond the solar system. One hypothesis suggests Earth may have passed through intense radiation from a nearby supernova explosion at the end of the Cretaceous. A massive gamma-ray burst could destroy the ozone layer within months. Without this fragile shield, all surface life would be defenseless against lethal solar ultraviolet. It wouldn't kill everything instantly, but it would initiate total degradation of flora and fauna. Another scenario involves Earth's invisible armor, its magnetic field, our primary shield against solar wind and galactic cosmic rays. Geological evidence shows periods of magnetic reversal or sharp weakening. If the field sagged during an ecological crisis, the planet would be flooded with high-energy cosmic particles. This could trigger an avalanche of genetic mutations, mass infertility, and sharply reduced lifespans among large species. Although direct paleontological evidence for stellar death remains scarce, this theory reminds us that our planet is merely a tiny, vulnerable vessel adrift in an often hostile cosmic ocean. Sometimes the threat arrives not as a blazing rock, but as invisible rays from distant stars capable of rewriting the history of life in an instant. Synergy of catastrophes, the perfect storm. The truth revealed by modern science is far more complex and darker than any Hollywood script. The dinosaurs weren't killed by any single villain, they were killed by everything at once. We are dealing with what scientists call the perfect synergy of catastrophes. Picture a heavyweight boxing champion already exhausted after 12 brutal rounds. His head spins from oxygen deprivation. He bleeds from countless small cuts. His muscles are failing. Climate swings feverishly through his body, now burning hot, now freezing cold. The Indian volcanoes steadily poison the air he breathes. Resources for recovery dwindle. He barely stays on his feet, clinging to the ropes of a fading era. And at that precise moment, when the organism of the planet is maximally weakened, the final, devastating blow arrives from space, the Chicxulub asteroid. Dinosaurs were not evolutionary losers or a biological dead end. On the contrary, they were extraordinarily successful, dominating Earth for roughly 100 times longer than the entire existence of humankind. But they became hostages to a world literally cracking at the seams. The asteroid probably could not have completely eradicated them if ecosystems had remained healthy and adaptable. The volcanoes would not have finished them off without the sky being blanketed in impact dust. Each event alone was a severe trial. Together they created lethal resonance. Their doom was not one enemy, but a monstrous chain of coincidences in which every link amplified the previous one. It was a planetary-scale system failure against which the giants of the past simply had no chance. After the end, a world without dinosaurs, heirs of the ashes, and when the multi-year dust finally settled decades later, and the first clean rays of sunlight touched the surface, the world was utterly unrecognizable. A ghost planet. Once teeming oceans stood empty, turned into lifeless saline deserts. Great forests had burned to the ground, leaving only layers of charcoal. A dead, ringing silence hung over the planet. No more thunderous roars of tyrannosaurs. No more leathery flapping of pterosaur wings. More than 75% of all animal and plant species vanished forever, reduced to dust beneath the feet of history. Yet it was precisely in that eerie emptiness and graveyard cold that those who had spent millions of years lurking in the shadows of the great lords managed to survive. Our distant ancestors, tiny, unremarkable mammals, resembling modern shrews or rats. They endured the planetary hell because they could hide deep in burrows, were flexible about food, and possessed the great gift of patience. With the disappearance of the giants who had suppressed all competition, limitless vacant ecological niches opened before these little survivors. The monstrous catastrophe that ended one era gave our lineage its one unrepeatable chance. We must face the bitter truth. Without the death of the dinosaurs, humans would most likely never have appeared. We are the direct heirs of that terrible day children of catastrophe who built our civilization on the bones of fallen titans. Philosophical conclusion. Lessons from the Colossi. Dinosaurs ruled Earth unchallenged for an astonishing 160 million years. To grasp that scale, consider this. All of human history, with our technology, wars, and art, is but a brief flash compared to their reign. They were perfect creatures, stronger, larger, incomparably more enduring than us. Their dominion seemed unshakable, an eternal monument erected by life itself. Yet that great story ended almost instantly by the merciless standards of geological time. The fate of the great reptiles teaches us genuine humility before the universe. It shows vividly that neither colossal size, nor raw physical power, nor teeth sharp as razors can save a species when the cosmos suddenly changes the rules. We tend to think of our world as stable, but that stability is only a fragile illusion, a temporary calm between great storms. The story of the dinosaurs is not merely dusty pages in paleontology textbooks or museum exhibits. It is a stern warning addressed to us, the current tenants of this beautiful and extremely dangerous house called Earth. If you enjoyed unraveling the mysteries of the past, subscribe to the channel and leave a like. It really helps us create new videos. And what do you think? Will humanity be able to survive its own global catastrophe? Or are we also just temporary guests on this planet? Share your thoughts in the comments.